Welcome to 4.3. I'm coming to you today from the Kalen family condo in Palm Springs, California. I think I've done videos from here before, but um, not sure if I asked you uh, to see if you can find some information, special information about this region. But let me first show you. Here I am. You can see the beautiful palms of Palm Springs and other magnificent trees. Um, but what I wanted to do is to ask you to see if you can figure out for a point of assignment extra credit why Palm Springs is called Palm Springs. And then if you go to the east from here, I think the order of the towns goes Cathedral City, Rancho Mirage, Palm Desert, and then Indian Wells. Why is Indian Wells called Indian Wells? All right, so you can do that, send that to me, um, and I will get you a point of extra credit. Okay, so I'm gonna share my screen here. So 4.3, we're gonna start learning about how to write equations of parallel and perpendicular lines, so special types of lines related to each other. But go ahead and start the warm up. Here, the first two problems ask you to write an equation in point slope form, so remember what that is, of the line that passes through the given point and has the given slope. So remember y minus y sub 1 equals m times the quantity x minus x sub 1. Try those. All right. Well, hopefully you got y plus 7 equals negative 3 times the quantity x plus 5, and y minus 0 equals negative quantity x minus 2. And of course, if you didn't have the minus 0 and you simplified that, that's fine. But basically, that's the form you would leave it in. Okay, and then for the bottom two, write a sentence as an inequality, graph the inequality. So this would be simple graphing on a number line. Give them a shot. Okay, so hopefully you had n sandwiched between negative 11, including negative 11, and less than negative 6.25. And if you went to graph that, hopefully you had something that looked like that. Remember this stuff from chapter 2? And then for the second one, you'd have to write it as an or, right? No way you can have a number that's less than that and greater than that. And notice we have the word or there. So what would that look like? It would look like that. Okay. All right, back to kind of what we're covering here. Your learning target is to be able to recognize lines that are parallel or perpendicular and even be able to write equations for them. Okay, so find your imaginary partner or catch up with somebody. Do it together. I don't know. You're going to write each linear equation in slope-intercept form. So there's 6 equations here. You're going to write them in slope-intercept form. Remember what that is? Y equals mx plus b. Very good. Then I want you to use a graphing calculator. And you can go to Desmos to do this if you want. Remember, go onto Big Ideas, hit the 3 bars in the upper right corner, or you may have it down in Math Tools, but find Math Tools, and then click on Desmos Graphing Calculator. And then graph the 3 equations, these 3, in the same square viewing window. Remember how you can do that. And that way you can find out which 2 are lines of pure parallel. And how could you tell? You'll answer that question. Oh, I got that uncovered there, don't I? Their slopes are the same. And then you can do the same thing for these. Okay, so give that a shot. All right, so hopefully when you put these first 3 into slope-intercept form, you got that. And then you went and you graphed them, and what did you notice? The first 2 are parallel. Yeah, the first 2 are parallel. Why? Same slope, and different y-intercepts. If they were same slope and same y-intercepts, then they would be the same line, right? Okay, awesome. And this one would also slope down to the right, but it would not be parallel. It would be steeper. Okay, how about these 3? Go ahead and do it. So hopefully you got those 3. And which 2 are going to be parallel? Hopefully you said the first and third one. Okay. And here's this one graph down here, right? And obviously this one would have the same y-intercept, right? But it wouldn't be quite as steep because its slope is -2 as compared to -5/2. And this one would have a y-intercept up here at 5, but it would have the same slope. Okay. All right. Then I want you to basically try the same thing with this one, but this time we're trying to figure out which two lines appear perpendicular. And for those of you that maybe don't remember that, remember perpendicular lines form right angles. So they come in, you know, like that, okay? All right, so try the 3 on the left. Okay, hopefully when you transformed them, you got this. And then when you put them into Desmos, you realize that it was the first and third ones that are perpendicular. Okay, so check those out. Look at their slopes. And then so you can see down here the graph of the first one. And what did this graph of this last one look like? Well, didn't it kind of come in at this kind of an angle and formed a right angle? Okay, and then try the last 3. Okay, hopefully you got those. And which two appeared to be perpendicular? The first and thirds. Okay, slope of 2.5 or 5/2 and a slope of -2/5. Whoa, how about that? For each set of 3, the 2 that were perpendicular had slopes that are called the negative reciprocals of each other. So let's take -3/4. What is the reciprocal of -3/4? It's -4/3. But then you take the negative and the negative and it becomes positive, and voila, we have 4/3. Or if we take 2.5, which is 5/2, and we flip it, we get 2/5. And then slap the negative sign on it, we get -2/5. Negative reciprocals. Okay, so into the lesson we go. Parallel lines, we're going to start with those. Parallel lines and slopes, 2 lines in the same plane that never intersect are called parallel lines. Now you might be saying, can 2 lines never intersect that are not in the same plane? And the answer is yes. You could have 2 lines that are like this. They never intersect. They're not in the same plane. They're called skew lines, S-K-E-W, for you trivia fans. And actually you'll get into that in a much bigger way in geometry or honors geometry. Okay, non-vertical lines are parallel if and only if they have the same slope and different intercepts, because otherwise they'd be the same line. So parallel lines, same slope, different intercepts. All vertical lines are parallel. Yep. Now, why did they have to write that? And why did they have to write non-vertical lines up here? Because vertical lines don't always have the same intercepts, right? In fact, they could not have a y-intercept at all. They would have different x-intercepts. Okay. Okay, so what do we want to do? If we want to determine which of these 3 lines, A, B, and C, are parallel, we would need to figure out what? Yeah, we need to figure out their slopes. Okay, so you can see that the slope of these, A and C, are -1/5. B has a slope of -1/4. So right there, you can go ahead and rule out B, right? Because they don't have the same slopes. And do A and C have different intercepts? Well, clearly, yeah, the y-intercept up here, right, is 2. The y-intercept for C here is about -4.5-ish, I guess. And the x-intercepts for A, it's way over, going to be way over here. And for C, it's going to be kind of way over here. So lines A and C are parallel because they have the same slope and write in and different intercepts. Okay, so here I want you to write an equation of the line first in point slope form, and then I want you to transform it into slope intercept form that passes through 5, -4, and is parallel to the line y equals 2x plus 3. Well, as we know, we got to have two things in order to graph a line. You got to have a point and you got to have a slope, okay? We have a point, don't we? 5, negative 4. Do we have a slope? Were we given slope straight out? No, we were not. But we were given a hint in order to figure it out, and that's that our line, our equation that we have to write, is a line that's parallel to this one. So if we can figure out the slope of this one, then we know the slope of ours. And this one happens to be in what form? Yeah, slope-intercept form. So we know that 2 is what the slope is of that one, which means that our line also has a slope of 2. So m equals 2. So we can plug into point slope form, plugging in negative 4 for, y sub 1. So it's y minus negative 4, which becomes y plus 4. Plug in 2 for m, and then it's x minus x sub 1, or in this case, x sub 1 is 5. Now, so we did that point slope form, but now we have to write it in slope intercept form. So we've got to do what? Yeah, distribute and get that y isolated by itself. Okay. Now, there's another way that you can get to slope-intercept form, and that is by figuring out what b is, right? Because we know 5, negative 4 is a point that's on the line, right? And we know the slope's 2 from doing this work. We could plug in negative 4 for x, I'm sorry, for y, excuse me, negative 4 for y, 5 for x, and solve for b. And if we do that, we would subtract 10 and we get negative 14. So if I know b is negative 14, and I know the slope is 2, can't I just write that into y equals mx plus b form as y equals 2x minus 14? Now notice though that that doesn't help us in terms of writing in a point slope, and we had to do that too. So, but anyway, different way of doing it. And again, that's because we know 5, negative 4 is a solution to that equation because it falls on that line. Okay, so here, second one, we have line A passes through negative 5, 3, and negative 6, negative 1. Line B passes through 3, negative 2, and 2, negative 7. Are the lines parallel? Well, first thing we'd want to check is what? Yeah, do they have the same slope? If they don't, we know they're not parallel. So if you figured out the slope of them, for slope of line A, one way to do it would be negative 1 minus 3 over negative 6 minus 5. Remember that? Or we could have gone the other way, but either way, we're going to end up getting 4. And for line B, calculate the slope. Hopefully you ended up getting 5, either doing it the way I did or reversed, right? You could have gone negative 2 minus negative 7 over 3 minus 2. And in that case, you would have gotten 5 over 1, which is still equal to 5. So what do you think? Are they parallel? No, they have different slopes. How could they be, right? They're going to eventually hit each other. Okay. All right, next problem. Write an equation of the line in slope-intercept form that passes through negative 4, 2 and is parallel to this one. All right, so think about it. You need a point and a slope to get started with this, right? We weren't given the y-intercept, so we can't go straight to slope-intercept form at this point, or could we, using the other way that I showed you just now? But anyway, if you decided to go the quick way, you noticed that the slope of this one was 1/4. And since ours is parallel, that the one that we have to write the equation for is parallel to this one, we know we have the same slope, so our slope is 1/4 also. And I know I go through negative 4, 2, so I can plug in 2 for y, negative 4 for x, and then solve for b. And then once I've solved for b, these 3, right? Because this is equal to 1 or negative 1, and then I have negative 1 here plus b, so I'd add 1 to both sides. 2 plus 1 is 3. I now have b, I have the m, so I could write it in slope-intercept form like that. Or I could use this point and write it in point slope first. And then what would I need to do? I need to distribute and get rid of that negative 2 off that side. So if I distributed and then added 2, I get to the same place. And remember, as we talked about in a prior lesson, you can have different nicknames, right? But you're only going to have one correct slope intercept for a line. All right, moving on. So this would be a great time to stop. We finished with parallel lines. Now we're going to get into perpendicular lines. So if you want to take a break, go for it, but then come on back. Okay, so perpendicular lines and slopes, two lines in the same plane that intersect to form right angles are perpendicular lines. We just talked about that. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. If you take 1/2 and you flip it and then slap a negative sign, you get -2. If you take -2/1 and you flip it, you get -1/2 and then slap a negative on the negative, you end up with +1/2, negative reciprocals. Now we have to have a special case or say something special for vertical lines or perpendicular to horizontal lines, right? Do they have opposite reciprocal slopes? Not really, because you can't have a reciprocal of 0, right? 0/1 would be the reciprocal that would be 1/0, which is undefined. So technically we can't write it like that, but same concept applies, okay? All right, so if I ask you to determine which of the lines are, if any, are parallel or perpendicular, what would you need to do first? Yeah, figure out their slopes. Pretty easy with line A. Why is it so easy to figure out the slope? What form's it in? Oh yeah, y = mx plus b. So the slope is, hopefully you said the number right, between 3 and 5, otherwise known as 4. Line B, not quite so easy, not in slope-intercept form. So remember, you could always take -a/b, which would be a is 1, right? So -a/b would be -1/4, or you could subtract x from both sides and divide by 4, and you get -1/4. That looks interesting compared to that one, but let's get to that analysis in a minute. For C, again, you could do it two different ways. You could take -a/b from standard form, right? Be careful, a is actually -2, right? Or you could do it the way we're doing it there and you get -1/4. So which lines are parallel? Yes, these two. Why? Same slope, different y-intercept, right? The y-intercept on this one is going to be 3/4 when I divide everything by 4. Here it's -2. Are any of them perpendicular? Yes, both B and C are perpendicular to A, or A is perpendicular to both B and C. Why? They have opposite reciprocals or negative reciprocals. Okay. Yeah, so lines B and C are parallel because they have the same slope and different intercepts. Line A is perpendicular to both lines B and C because their slopes are negative reciprocals. Okay, let's try this next problem. Write an equation of the line in slope-intercept form, y = mx plus b, that passes through -3, 1 and is perpendicular to this, to the line that has this equation. Did they give us a point? Yes, -3, 1. Did they give us the slope? Well, not directly, but we can figure it out. What's the slope of this one? It's in slope-intercept form. Hopefully you said 1/2. What's ours going to be? Oh, ours is perpendicular to this one, which means that I need to take the slope of that one and take the opposite reciprocal of it. What's the opposite reciprocal of 1/2? Flip it, negative, -2. So m's -2. I have a point. What can I plug into to start with? There you go. One way to do it would be just plug into point slope. Distribute, add 1, and you get y = -2x minus 5. Or again, you could have done it the other way and just plugged into y = mx plus b using -2 for m, -3 for x, 1 for y, solve for b, and then we're good to go. Okay. All right, so try that on this next problem. All right, so hopefully you got slopes of -1/3, 3, and 3. So which ones are going to be parallel? Yeah, B and C. And A is going to be perpendicular to both B and C. Okay, and then try this problem. Write an equation of the line in slope-intercept form that passes through -3, 5 and is perpendicular to this one. It's very similar to the bottom on the previous slide, so you can always look at that one. Just figure out how to do this. So this other one has a slope of -3. Ours is opposite reciprocal, 1/3. Plug it into point slope. Simplify to get it into slope intercept form. So you always got to make sure you're putting it in the right form by the time you get to the end. And again, could have done it the other way, plugging -3 comma 5 and 1/3 into straight into y equals mx plus b. Figure out what b is. You would have gotten 6 and then used the 1/3 and 6. All right. Oh, I love this problem. Position of a helicopter search and rescue crew is shown in the graph. Okay, there it is right there at 14.4. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Okay, so here's the shore. See it in green? See the shore? Here's the water over here, right? We're trying to get to the shore, which is on this side of the green line, or the land that's on the left side of the green line. There's the shore. Write an equation in slope-intercept form that represents this path. Okay, so we have a point, don't we? We need to find the slope of this line. Well, how can we do that? Couldn't we find the slope of this one? And then we know ours is the opposite reciprocal. So slope of the green line is -2/3. Notice if I pick a point, I'll pick that point right there. I go down 2 and over 3 to get to the next intersection of crosshairs, right? Down 2 over 3, down 2 over 3. So what's our slope going to be for our line, the red line? Hopefully you said the opposite reciprocal of -2/3, which is 3/2. Yay. And don't we have a point for our line? We do. So we would plug in to point slope. And then they wanted us to write it in slope intercept form, so we're not quite done. Got to distribute and simplify. How could we check? We could find any other point on our line and plug in the coordinates. So looks like here's one. This is at what, 10, -2 right there. If I plug a 10 in here and a -2 right here, if I plug a 10 in, the 2 and the 10 cancel and become a 1 and a 5. 3 times 5 is 15. 15 minus 17 is -2. What did I plug in for y again? Oh yeah, -2. Check, check, it worked. Okay, now we have a boat that's traveling parallel to the shoreline and passes through 9.3. 9.3. So it passes through 9.3 right there, okay? Write an equation in slope-intercept form that represents the path of the boat. So we want to find the equation for the line that goes through here. Well, what if it's traveling parallel to the shoreline, how will the slope of the boat's path compare to the slope of the shoreline? Hopefully you said they will be the same. What was the slope of the shore? -3/2. What's our slope then? -3/2. I'm sorry, I said -3/2. I meant -2/3. Hopefully you caught me. -2/3. Okay, and do we have a point? Yes, we do. 9.3. Plug it into point slope is one way to go. Distribute, combine, or add 3 and combine, and there you have it. Okay, and I believe that is the end. No, it's not. We have one more page. Excellent, love it. Writing prompt. To write an equation of a line that passes through -2, 4 and is parallel to y equals -3x plus 4, finish it off. What would you write if you were explaining to someone how to do that? Your far-flung lost pen pal that lives in Mozambique. I've never been to Mozambique. My parents have. They say it's lovely. One, determine that the slope of the line I want to write an equation for is -3 because it is parallel to the other line that has a slope of -3. How do I know that? It's in y equals mx plus b form. 2, plug my 3 numbers into point slope form. So I'm going to plug in the -3 for m. I'm going to plug -2 in for x sub 1 and 4 in for y sub 1. And if requested in slope, intercept, or standard form, then I would manipulate the equation into the requested form. If they asked for it in point slope, then I'd be done after step 2. I hope you have enjoyed 4.3. One more section to go in chapter 4. And I look forward to getting your responses to why Palm Springs is called Palm Springs and why Indian Wells is called Indian Wells. Talk to you later.